We have been finding and writing equations of lines. Let's now practice finding special equations of lines. I'd like to write an equation of the line that's parallel to the graph of this equation, but through that point. Now, by the way, what type of special line is the graph of y equals 5? Y equals 5, do not forget, is a horizontal line. So what kind of a line is parallel to a horizontal line? It's another horizontal line, and a horizontal line has equation y is equal to some constant. So if I want a horizontal line through this point, it will have the form y equals c, and in this case, it's y is equal to the y value of the point y equals 2. If you graph y equals 2, this graph will go through this point, and it will be parallel to the graph of y equals 5. Let's try another special case. Let's suppose we want to write an equation of a line with undefined
Daniel,
slope.
don't touch that.
Now think about that a minute. With undefined slope through, and then let me give you a point. -3/4, 1. Now, undefined slope should have a meaning to you. Undefined slope should mean it is a vertical line, and a vertical line should have a meaning to you also. It should mean all vertical lines have the form x equal a constant. So I want to write an equation of the line with undefined slope. That means a vertical line. That means of the form x is equal to a constant. And I want a vertical line specifically that goes through this point. So if it's going to go through this point and have undefined slope, it must be x is equal to this x value, -3/4. If you graph this, it is a vertical line, so it does have undefined slope, and it will go through that point. Now that we know our forms of
Okay, guys,
equations
this is
of
the
lines,
last objective we need for this set of
let's use
notes.
those forms to solve applications. Let's look at the following. A rock is dropped from the top of a 400-foot cliff. After 1 second, the rock is traveling 32 feet per second. After 3 seconds, the rock is traveling 96 feet per second. Here's part A. Assume that the relationship between time and speed is linear and write an equation describing this relationship. Use ordered pairs of the form time, speed. So remember, we are to use ordered pairs of the form time, speed. We're told after 1 second, the rock is at a speed of 32 feet per second. After 3 seconds, it is at a speed of 96 feet per second. Now, let's use this and the fact that we were told that this is a linear relationship. Let's write a linear equation describing this relationship. To do so, we've got 2 points. How do we write an equation? We can use the point-slope form. So let's find slope. Slope is equal to y minus y over x minus x. Well, let's see, what is 96 minus 32? It is 64. 3 minus 1 is 2, and 64 divided by 2 is 32. So our slope is 32. Now let's write down the slope, or the point-slope form, and let's write our equation. Remember that the slope is 32. I'll write that down. Our slope is 32. And then remember the point-slope form. Y minus y sub 1 is equal to slope times x minus x sub 1. So choose a point. It makes no difference what point you choose. I'll choose this point, and of course that slope. So y minus The y value of 32 is equal to a slope of 32 times x minus the x value of 1. So we have y minus 32 is equal to, now I'm using the distributive property, 32x minus 32. Look what happens if I add 32 to both sides. The 32's subtract out, and I have just y is equal to 32x. So here we have an equation describing the relationship between time and speed. Now let's look at part B and see what we are asked to do with this. Use this equation to determine the speed of the rock 4 seconds after it was dropped. So now that we know what we are asked to do, if you'd like, we can give more meaning to this equation by using s for speed and t for time instead of y and x. Now let's see which one is speed and which one is time. Well, let's remember how we set up our ordered pairs. Remember, this one was time, 1 second, and this was speed, 32 feet per second. So the x value was time, and the y value was speed. So the x value was time, y value was speed. In essence, we also can write it as speed is equal to 32t, t being time. It just gives it more meaning, that's all. Either of these is correct because we were letting x represent time anyway. But now we want to know what is the speed of the rock 4 seconds after drop. So I think it's easier looking at this to see how we find that answer. 4 seconds after it was dropped, that is a time. So let me write this so we'll have more room. We do know that S is 32t. To find the speed then 4 seconds after it was dropped, the speed is 32 times the time of 4 seconds, and that is 128. Now, what is that speed? We should write units in. That speed is feet per second. So, 4 seconds after the rock is dropped, the speed of the rock is 128 feet per second. At this time, practice working with equations of lines. Now that we know how to calculate slope, let's look at an application and let's view slope as a rate of change. Let's look at the following. The graph shows the total cost Y in dollars of owning and operating a compact car, of course excluding the cost of the car, where X is the number of miles driven. So notice we have this line graph, and notice we have 2 points with ordered pairs noted. So we use those 2 given points or those 2 given ordered pairs to calculate slope. So there are our 2 ordered pairs that were given. We'll find slope just as usual. How do we find slope given 2 ordered pairs? Slope is y minus y over x minus x. So y, 9,400 minus y, 2,350 over x, 20,000. Remember, x had to do with miles and y has to do with cost. There we go. So if you subtract, let's see, that's 7,050 over 15,000, and then divide, and you'll have 47 hundredths. So that's 47 cents, but that's my slope, and we'll look at it as a rate of change. So think of it as maybe this amount of money over 1. Remember now, this denominator, which is what? the X values, that has to do with miles. So what does that mean? It means that it costs this much money per 1 mile
No.
to own and operate. And this is how we're viewing slope as a rate of change. And that's how we're writing it in this application. It costs this much money, remember those are the Y values, money, per 1 mile to own and operate. I think it's a compact car.
Okay.
All right, at this time, practice calculating slope and looking at slope as a rate of change.